Friends, in this session, we are going to see the continuation of the previous session. That is a electric field at an equatorial point of a electric dipole. That is a electric field of a electric dipole along the equatorial point. The distance between the origin, that is a center of the dipole, and the particular point P at the normal to this dipole is R. So this charge and plus charge and minus charge are separated by a distance 2a, hence this is a and a. So by using the Pythagoras theorem, this is a right angle triangle, this is a theta, so we get this length is equal to r square plus a square, the root, so the root of r square plus a square. So the distance of the charge plus charge from the point P is the root of r square plus a square. Similarly, the distance between the minus charge and the point P is root of r square plus a square, the a square. So, but for the axial line, this is not equal. Now you see that for positive charge, the distance is r minus a the whole square. For negative charge, it is r plus a the whole square. Now, you consider that at the point P, the electric field direction of the positive charge is along outwards in this direction, and at the point B, the electric field direction of the negative charge is pointing towards a negative charge. That is, for electric field of the positive charge is move away from the positive charge, the electric field of the negative charge is moves towards that is directed towards a negative charge. So this electric field is a vector. It has two components, both horizontal and vertical components. Always we have to represent the vertical component as sin theta and horizontal component as cos theta. So we get E plus Q sin theta and E plus Q cos theta as vertical and horizontal components, and E minus Q sin theta and E minus Q cos theta as vertical and horizontal component. So what is the electric field formula for positive charge? E plus Q is equal to plus KQ by R plus A the whole square. What about the root? So it is a KQ by R square. So root of R square plus A square the whole square. That root and whole square will be get cancelled. We get only R square plus A square. Similarly for the negative charge also, minus KQ by R square plus A square. Since you students you note down that here the magnitude of the two electric field, plus charge and minus charge electric field are same, only the sign only changes. So the magnitude are same, so we can write that electric field simply E is equal to E plus Q, which is equal to E minus Q. So that means the vertical component of the plus Q and the vertical component of the minus Q are equal and opposite. These two will be cancel out each other. Only the horizontal component of the E plus Q and the horizontal component of the E minus Q will add up each other. Hence we get the answer. The resultant vector will be along in this direction. That is a total electric field of the electric dipole at the point equatorial point. So that is equal to 2E cos theta. Hence this diagram evidently clearly shows that the vertical component of the plus Q and minus Q will be cancel out each other, and the horizontal components will add up. Finally we get the equation E equivalent, which is equatorial, which is equal to 2 times of E into cos theta. What is this E? This E is a electric field, either the magnitude of the plus charge or minus charge, because both the charge magnitude will be same. So finally we get the answer 2E cos theta. So what is this cos theta? This is a theta. So theta can be taken as a cos theta. So cos theta is by the trigonometrical formula adjacent side by hypotenuse. Which one is adjacent? This is adjacent side. This is a hypotenuse side. We get the answer cos theta, which is equal to A by root of R square plus A square. So by substituting this cos theta value also here, we get 2 into KQ by R square plus A square into A by root of R square plus A square. Because this E value is from this equation we can take on that. So Q into 2 into A, Q into 2A K. So this numerator will be comes here. Then in denominator R square plus A square, the root will be there. We can write it as a whole power 3 by 2. Hence we get the answer Q into 2A is a dipole moment. It is represents the equation dipole moment P. So we can write that kp by r square plus a square whole power 3 by 2. This is the equation which represents the electric field of an electric dipole when the point will be at a equatorial point. So when this point will be taken as an infinitely long distance, this r value is very greater than this small a value. Hence, when r is very greater than a, then a can be neglected in this above equation. So we can write that r square whole power 3 by 2. So the square and the 2 will be get cancelled. We get the answer E equatorial, that is a equatorial point. Total electric field of an electric dipole along the equatorial point is equal to 1 by 4 pi epsilon naught P by R cube. This is a unit vector. So students, it is easy to remember that for the axial point, it is a 1 by 4 pi epsilon naught 2p by r cube. Here for equatorial line, it is 1 by 4 pi epsilon naught p by r cube. So only the 2 will be extra term. So we have to relate these two equations as E axial line is equal to 2 times of the E equatorial.